All right. Welcome back, everyone. Today, we are happy to present American Battery Metals Corporation. It trades on the OTCQB under the symbol ABML and is uniquely positioned to supply battery metals through its three divisions: lithium-ion battery recycling, extraction technology, and primary resources. Joining us today is American Battery Metals COO, Menka Sethi. Welcome, Menka.
Hi, well, thank you for including us here today. Really happy to be here.
Sorry, Menka. I said that incorrectly. Menka, welcome. Glad you're here.
Thank you.
Whenever you're ready, take it away.
Okay, fantastic. Thank you. Yeah, so really happy to be here today on behalf of American Battery Metals Corporation, soon to be named American Battery Technology Company. So you'll see ABTC throughout my presentation today. As Anna mentioned, we're a company focused on increasing the supply of battery metals, and we've built a clean technology platform that's allowed us to put in place a multi-pronged approach, many different ways to source battery metals that I'll run through here shortly. And our goal is to put in place a circular economy for the metals, recognizing that if we do this in the right way, we can source the critical materials needed to power EVs, consumer electronics, cell phones well into the future in a way that not only works clearly for consumers and industry, but also addresses climate change. So you'll hear that ESG bent throughout what I say today. And if you look at our business model, there's three key problems that we're trying to solve. The first is limited supply of battery materials. So as we've heard recent announcements from GM, Volkswagen, others, that's escalating their investments in electric vehicles. And as we've heard from the new administration in the United States, the White House, about the need to address climate change, the need to secure supply chains, all that goes back to increasing demand for the metals that feed the batteries that power our everyday lives. And those metals right now are in increasingly short supply relative to the escalating demand. So that's the first key problem that we're addressing. The second key problem, as I've already alluded to, is the supply chain. So that for these metals that feed into the batteries that power the EVs and power the cell phones. Right now, the materials are coming from only a handful of locations around the globe. And those locations do have geopolitical instability. They have very few environmental frameworks, and there are human rights issues as well. So our company believes if we can establish a domestic source for the critical materials, that we are in fact securing the supply chain. And then the third key problem that we're addressing is really a new suite of technologies that brings recycling into the new age, where our approach is much more low impact in terms of the environment, and it's also inherently more profitable. So doing well by doing good, hide in the green process that is in and of itself more economically feasible and much better for local communities. So these are the three problems we've been addressing, and the way we're addressing them is through our platform, our three-pronged approach to sourcing the battery metals. Our first business line is through recycling. We're pretty far along in launching this business line, and I'll speak more to that later, but that is the quickest way to extract and produce battery metals by taking lithium-ion batteries, demanufacturing them, and then separating out individual components of what was in the battery and refining them into high-grade battery metals that can be sold directly back into the market. And our process can do that in hours. The second prong of our business plan are the extraction technologies. What are the extraction technologies? That's the suite of chemical processes, mechanical processes that we can apply to whether it's a lithium-ion battery or whether it's a brine or a claystone deposit. We are able to apply these chemical processes to very quickly and cleanly extract the battery metals. And the third prong of our business plan is resource stewardship, We do have mineral claims of our own in Nevada, and we will be applying our own extraction technologies to those new resources to unlock domestic supplies of critical materials such as lithium. The next slide here, I wanted to take one moment and talk not specifically to our technology, but to the way we run our business. And this is really, the next evolution in our company that we're really proud of. I believe does set us apart from competitors as well, and really helps us take a leadership position in the industry, and then our policy work, which I'll speak to shortly as well. But these are 5 principles we've gone live with in an op-ed last December. And again, it reiterates our goal to secure supply chains for battery metals in the United States. I think the domestic component here is really key. There's only a handful of companies looking at battery recycling, and not many of them are. There's also other mining efforts and extraction technologies being pursued globally. Not many of those are taking place in the US. In fact, if we look at the supply of some of the key battery metals coming from the US, such as lithium or so, it's only a few percentage points of the total global supply that's actually sourced from the US. So relative to the demand profile that we present, there is a mismatch there. So we are looking to secure the supply chains by producing domestically the battery metals. The number 2 principle here really reiterates our commitment to addressing climate change. We do that through our technology itself. Our recycling and extraction technologies are inherently low impact in that they emit very few near zero air emissions, both GHG and particulate matter. Our pilot plant that I'll speak to in a little bit that we're building has on-site wastewater treatment and recycling. So we have very low water use, and it will be powered by on-site renewable solar energy. So we are going as far as we can to show that our technology process, which is in and of itself very green and low impact, is complemented by a very low impact building. So we're really proud of this. And it's very different than some of the other technologies, the high heat smelting pyro metallurgical processes that you'll hear about from other industry players as well. The third operating principle here that we're really proud of is our commitment to empowering people and place. So our business model, because we have very high throughput times in our recycling capacity, we are able to have a very economically viable model that allows us to commit to things like living wages. And we are building our first pilot recycling plant in an opportunity zone in the Reno metro area so that we can increase economic opportunity for all, most especially communities that have been a bit left out of that economic opportunity in the past. The 4th principle here, again, greening the industry. We are working alongside government of local, state, and federal levels to provide our expertise about the tension points we face in scaling our technology, and the tension points we see in permitting, operating our green technologies for lithium battery recycling that don't neatly fit within the current environmental regulatory framework that was conceived of 40 years ago. So there is a thought partnership where we provide the expertise on the technology itself. We understand better than most, the performance profile of lithium-ion batteries, and we're able to translate that into frameworks that policymakers might consider to ensure that the industry can scale nimbly and quickly in the United States while also protecting environment and communities. So we're one of the few voices at the table. There's lots of excitement right now, as you may have seen from the executive orders that have come out of the White House, over the 30 bills that have come out of the federal legislature that pertain to what we do. And then the work of individual state environmental regulators that are trying to figure out how do we apply current 40-year-old EPA regulations to this new growing industry. So we're leaning into this opportunity, and we believe it will benefit not only us, but our industry, but in both the near term and the long term, again, by enabling more nimble innovation and speed of scaling. And that speaks to the A fifth point as well here, again, a little more tactical. We are using our commitment to greening the industry and working with policymakers to look at new frameworks that could be applied either at local, state, or federal levels to figure out ways to clarify the current hodgepodge, very complicated network of regulations that apply to building new industrial processes and then storing and transporting what some might consider hazardous waste, we might consider a commodity. And that's, again, goes back to the circular economy that we're trying to put in place for lithium batteries. In the current context, lithium batteries at the end of their life are considered waste and they're treated as waste. And we're trying to come up with a framework that matches what other regions around the globe are pursuing in the EU and China to ensure that the US remains competitive, that we do not lose this global race, that we can, in fact, work together with a broad coalition, broad group of stakeholders to put in place this framework that's more clarified, more streamlined, and really does recognize that batteries at the end of their life don't need to be considered waste. They are in fact a very valuable commodity that contain materials that can be reused again more efficiently, more in a way that's more environmentally friendly, in a way that's very economical and can help us bring manufacturing jobs back to the United States. If we can figure out how to clarify this regulatory framework. So those are some key goals we're working really hard to achieve. The next slide here speaks to demand. I alluded to this before, but again, there's been many announcements by large OEM car manufacturers looking to increase the electric fleet and in general to transition our economy to a clean energy economy. All of that will require more battery metals. And sometimes I think we take for granted that, by driving an EV, we are doing our part in addressing climate change, transitioning to a clean economy. But one thing that is often left out of the narrative is you can't build the EVs if you don't have the materials that go into the batteries. And right now that is a crunch point. So we cannot scale fast enough. And again, we are pushing our recycling business line ahead very fast, because again, we can extract and produce those battery metals from existing batteries, many of which are going to the landfill, in hours, and sell those battery metals back into the marketplace. That is compared to weeks or months with the traditional extraction technologies that we have since moved away from, that we have innovated far beyond. And that is much shorter. The days are much shorter hours than the years it takes to pull new materials out of the ground. And by some estimates, in the next 10 years, there will be over 11 million metric tons of lithium batteries that reach the end of their life. So if we don't scale recycling now, we miss a huge opportunity to convert what is now considered waste into battery metals that can be reused in the supply chain. So again, hitting home the supply chain risks, how big of an opportunity we see here, especially on the recycling side, enabled by our extraction technologies, is if we think of the 11 million metric ton figure, the number of lithium batteries some expect reach the end of their life in 10 years. Right now, there's a range of estimates on what percentage of those batteries are actually recycled. On the low end, there's 5%. Are recycled. That's kind of an older figure, and there's some higher numbers coming out now. There's not great data, but I can tell you it is far less, orders of magnitude less than what other industries have been able to achieve, such as lead acid battery recycling. So rates of recycling for lead acid batteries are near 99%. So we have a long way to go for lithium-ion battery recycling, and the economic opportunity that presents for our business and others is very clear, and it's very powerful, one that we're really leaning into, and it's the reason why we're pushing ahead our recycling business line first. The other interesting part about the supply chain, again, have mentioned previously, the sources of battery metals globally are clustered in a handful of fairly unstable countries. So the sooner that we can establish domestic supplies, the sooner we can secure the supply chains for companies and consumers in the United States. And that's where American Battery Technology comes in. We are, in fact, growing in the United States, in our home state of Nevada, that has been incredibly welcoming and partners alongside our growth. And that enables us to not only secure the supply chain, but also has the side benefit of bringing manufacturing jobs back to the United States, badly needed. Again, this slide speaks to how does our process, we have the three prongs. We have resource stewardship, extraction, and recycling. The reason, again, why recycling and extraction are moving ahead first is resource stewardship mining can take years, up to 5 years, to turn a new mineral supply into battery or metals that can be sold to cathode manufacturers and those making batteries that power our everyday lives. And we expect that the demand, again, for the battery materials is growing far faster than could be met through new mining sources. So there really is an imperative to move forward the technologies that can move the fastest. So example, the lithium demand gap alone by 2030 is eye-opening here. 1.67 metric tons supply, 2.2 million metric tons demand. There's a deficit there, and the way we're going to fill that deficit, in addition to mining, which takes years, will have to be through recycling and new extraction technologies, which we've recently won a grant by the Department of Energy in partnership with DuPont and American Lithium, where we are going to be applying our extraction technologies to Nevada claystone deposits, and we will show that it is possible to extract within hours lithium from those new claystone deposits. So we are moving the needle. The challenge is there to increase the supply of the battery metals faster, and that's exactly what we're doing. And again, this is more data showing the major lithium producers right now, what their targets have been, and where they've actually come in in terms of production, and they're falling short. And this goes back to how hard it is to extract new materials from the ground. I'm not saying recycling or extraction are easy either, but they are faster. So there is a speed game here, and that's where our technologies can help. And some of the key benefits of focusing on recycling and new extraction technologies first are, again, they reduce e-waste and they reduce reliance on mining. There's some great data that's come out of the EU recently showing that if we can scale recycling and extraction technologies faster, we can reduce demand for key metals like nickel and cobalt by 25 up to 50% in the coming decade. So again, there's a huge opportunity here through the recycling to not consider our spent batteries waste, but to consider them a commodity, to treat them like that, and to put in place and scale the technologies that enable us to convert them back into high-grade battery metals. The third key point here that I'll hit home is unique to American Battery Technology Company, and that is the low environmental footprint of recycling compared to mining. Some estimates, for example, that say recycling can reduce greenhouse gas emissions by 25% relative to mining. Our technologies can even outperform those figures because we don't use high heat processes, because we use mechanical demanufacturing and a closed loop process. We're able to achieve really amazing environmental outcomes that reduces air pollution, greenhouse gas particulates, reduces water pollution, and also reduces water use by recycling and reusing what goes through our technical process. And again, here the slide speaks to the value of the battery metals, the critical materials that are in batteries themselves. They are, when you look at these type of figures showing how much the car batteries cost, the materials that feed into the car batteries cost, raw materials can make up 65% of the battery cost. When you think of that, it almost becomes a crime to throw the batteries into a landfill, to not plan for end-of-life reuse, and to not recycle. So this should hopefully show to you why we are very compelled to move ahead recycling robustly and quickly, and so that we can capture this economic value. In the long run, we do see the benefit that if we can recycle batteries to produce the critical materials such as manganese, lithium, cobalt, nickel, that in the long run, this will be good for industry, for companies like us. It will also be good for consumers and for OEMs because it can reduce the cost of the raw materials because our process is very fast and efficient. So there's a social benefit here as well as an economic benefit. And just to give you an update of how are we moving ahead our new work, we are building a pilot plant right now, our pilot lithium battery recycling plant in Fernley, Nevada, that's in the Reno region. We're going through the permitting process right now. It's a very laborious process, as it should be. The permitting processes are meant to ensure the community well-being, life safety, and to look at the impacts on environment. So there's a reason why they're robust. They do take some time. We are going through that process now. We expect to begin the grading work for our pilot plant in May, and we expect the plant to begin operations by the end of this year, and then ramping up full production in 2022. And at full production, our pilot plant will be able to recycle 20,000 metric tons of lithium batteries a year. To put that in context, right now, the data that we see globally suggests 100,000 metric tons of lithium batteries are recycled a year. And if that equals, on the low end, 5% of all lithium batteries, you can see that our 20,000 metric ton pilot plant is meaningfully increasing recycling capacity off the bat. And our business plan is to show that our technologies are fast, efficient, economically viable through the pilot plant scale, 20,000 metric tons, and to then very quickly thereafter scale to commercial scale plants, which would be 100,000 metric ton capacity plants. So recycle 100,000 metric tons of lithium batteries a year, and to scale from there to really help us leverage this great opportunity we see of the growing need for lithium batteries and preventing them from going into the landfill. So capturing the economic opportunity and also improving environmental outcomes while growing jobs for our local economies. It's a really happy suite of outcomes. So this slide also speaks to our extraction technology. So remember, this is the second business line that I introed at the start. We have battery recycling, we have extraction technologies, and resource stewardship / mining. The extraction technologies are the glue that holds all of that work together. It is the process whereby we can take a feedstock, and a feedstock might be a lithium battery at the end of its life. It might be brine, it might be claystone. And it's the chemical process, the extraction technology that we apply to that feedstock that allows us to extract the individual critical materials and to refine them to high-grade battery metals, nickel, manganese, lithium, and cobalt primarily. Our process is very unique in the sense that and they're highly proprietary as well. They have moved away from the old model, and this is just to give you a sense of how many steps are in the old model of recycling that uses high heat smelting processes that emit a lot of toxins into the air. And the traditional method has been, once you have a battery, you burn it. And again, that's the process that emits environmental toxins. And it is then a black mass is produced from the end of that burning process that has to be sent to others, where they can then refine that and extract battery grade metals. So our solution condenses this process under one roof, and it also removes the high heat process. So we are able to take the batteries, pull them apart through a demanufacturing process, and then chemically separate the individual components, and then sell the battery grade metals back to the cathode manufacturer, all in one place, all in one factory, and all very quickly. So that's a much more efficient process than this old process where there's shipping of the materials from one part of the process to perhaps even another country, to a different company where they do the back end chemical refining process. Then you ship it from there to the cathode manufacturer. The process itself from smelting is very inefficient. Many of the raw materials are never recaptured. Our recapturing rates are very high relative to the old pyro processes. So it's very exciting. And again, we're working to scale these recycling technologies through a pilot plant. And also we're progressing on the extraction technologies that we already have in place to address lithium batteries recycling. But we're also, through our DOE grant partnership with DuPont and American Lithium, fast forwarding, scaling the extraction technologies very quickly so that we can prove them in the field as well. And the refining of those processes, by the way, will be continual. We will have in our pilot plant in Fernley, Nevada, R&D labs as well, our global innovation hub, because as battery technologies change and as new mineral deposits are sourced, our extraction technologies will need to be nimble along the way as well. So we will need to continually refine them. So that is the purpose of the R&D labs in Fernley, so that we will evolve alongside battery technologies and discovery of new mineral resources. So I've already previewed what does this look like, our solution. It is the green demanufacturing process that allows us to take a battery into our process. We mechanically demanufacture it. There's shredding processes, there's mechanical separation processes, and the output of that first phase process is called black mass. The water that we use throughout this process is, again, it's recaptured, it's treated, it's reused. That black mass is then sent to the phase 2 of our technical process in the same pilot plant, where we then chemically extract the individual components. And even in that process, the reagents that we use in that chemical process are recaptured, they're reconfigured, and they're reused. So we are truly taking to heart to minimize impact, minimize the use of materials throughout the process. That's not only good for the environment because we do not need as many chemicals in the process, but it's also good economically because we do not need to buy more of those reagents, those chemicals, which can be quite expensive through our process. So it's kind of beautiful that the most green process is also inherently the most profitable process. And this is, again, a high-grade overview of our process. We disassemble the batteries. We extract the materials that are then purified, separated out in a closed-loop system. The water from this process is actually, it's cleaner than well water where our plant site is. So it's a very good process. And then we purify those metals to battery grade so that they can be sold directly back to the OEMs and the manufacturers. And this is where the real value of the system comes into place. The front end of our system is very quick. It's very clean. It produces black mass, which is in and of itself valuable. But the real value of our business plan is the ability on site to take that black mass, to purify the individual components, separate them, purify them to battery grade materials that we can then sell to our customers. So this process is quick, and it's this back end where the true economic value is produced. And here's, again, yet another diagram that shows how our process is in and of itself circular. So we are reducing the need for, or the supply, the need for new materials, critical materials to come out of the ground. We're increasing the speed at which the materials can be sourced through recycling processes. And we're putting in place this process where you can take a battery today that's at the end of its life and very quickly break it down, refine it, and extract the battery metals and sell them back into the marketplace. So it truly is circular, and that yields both economic benefits and environmental benefits. And it really is at the core of our business plan and why we see this as such an exciting financial opportunity. And with that, I thank you for your time, and I'm open to any questions that you might have.
All right, Menka, thank you so much. We do have quite a few questions.
Great.
And what are some of the biggest hurdles in front of you currently, and how do you plan to get over them?
The biggest hurdles right now is how quickly can we scale? How quickly can we undergo the very rigorous environmental permitting process? There's a reason why the environmental regulations, again, are so strict, and that's good because they protect health, life, safety, and the environment. But the real constraint that we're seeing, the tension point, is it's called Resource Conservation and Recovery Act, RCRA. It's a set of regulations that it's a federal set of regulations through the EPA that each state administers. And it never conceived of lithium battery recycling industry. In fact, there have been 3 tries to request to the EPA going back to 1984 to clarify the performance of lithium-ion batteries so that there could be some clarified approaches. And that study, that clarification has never taken place. So here we are, we're a new technology. There are a few other competitors out there, but generally, and this is one of the reasons why we have chosen to locate our pilot factory in Nevada, because they have one of the most aggressive climate strategies, and they understand deeply that what we do enables the growth of the clean the clean energy economy, but it also grows local jobs. So they are heavily motivated to be thought partners to find ways that we can work within the existing regulatory framework, but also to help us move faster. So it really is an element of speed. And the way we're overcoming that is, instead of, I come from Facebook and large and tech, and I'm really proud of the work that we did at Facebook to scale the company because we did it correctly. But there are others in big tech where it's kind of a philosophy of move first and break things and, apologize later. And that's exactly the opposite approach that American Battery Technology Company is taking, because we believe if we can be thought partners with the environmental regulators, that we help them find solutions to their goals. And then also, that helps us because they know that when we show up, we say what we're going to do. If we say that our process is going to look like ABC, then they know that they can believe us and that we will actually implement on that. So we have spent quite a lot of time identifying the tension points in the RCRA framework and different solutions that might that we could pursue, both as an industry, as state governments, perhaps even clarifying the frameworks at the federal level as well. So that's how we're mitigating it. We're being thought partners. We're working with deep experts in the environmental legal field. So across our consultant team, we're using our own technical expertise as well to help provide solutions. For example, one of the key tension points that's going to, make it not harder to scale, but slower to scale, is just figuring out all the different regulations that apply to storing and transporting hazardous materials. And then figuring out how to put in place the backbone infrastructure that can help a battery at the end of its life, whether it's at a car dealer or whether that battery is in someone's backyard, or sadly, if that battery is in a landfill. What is the infrastructure system that can very quickly and nimbly and safely get those batteries from where they are now to our pilot plant? That's what we need to unlock. And our technical team is perhaps the most qualified on the planet to figure out what is the safety profile and how can we safely accomplish the storage and transport that then can translate to give the regulators the comfort to translate that into new regulatory frameworks, because our technical team came from Tesla, where they spent years figuring out every which way a battery could have a runaway event. They tore apart the batteries, they put them back together, and their goal was to figure out how can you put it back together more efficiently, more safely, and how can it be recycled? So again, we can extract the economic value from the materials that are inherently inside the batteries. So we have been using that technical expertise to help the regulators figure out what their own solutions might be. So I'm very confident that we will attain the permits as expeditiously as possible because of that partnership. And it's not just unique to our pilot plant, but this is something I think, through Nevada, and again, it's really inspirational climate strategy, and it's extremely forward-thinking environmental regulators who partner not only with industry, but environmental advocates and social justice advocates at the same time. It's very bipartisan. There are solutions that need to be scaled nationally, because if we do not, our industry will not be able to scale quickly and nimbly, and we are not going to not only keep up, but we are going to lose the global race in lithium battery recycling, and we're going to lose the global race on making sure that American companies have access to the critical materials that we need to power electric cars, cell phones, consumer electronics. So it really is much broader than what we're doing, but that is the key constraint we face, and the way we are mitigating it is through open, transparent thought partnership and providing expertise openly.
Fantastic. Thank you. Response. This is so important. There are so many questions that we will send to you. We just have a few more moments. Let's talk a little bit about your uplisting process to the NASDAQ. Are you planning on doing a private placement? And if so, for how much? And what will be the main use of the proceeds for the funds?
So I can't speak to a lot of that, as you know, but I would encourage all the viewers, to look at the press releases we've made, we've uploaded our investor deck to our website. I would encourage you to look through that. And yes, we've been transparent that at the right time, we will be pursuing an uplist. I can't say much more than that right now. I can say, if you refer to the investor presentation, which is public, so I can speak to that. It does outline the source of proceeds, that we are looking, or the use of proceeds, and it's very clearly to fund and scale our recycling capacity and our extraction technologies. First and foremost, to build the pilot plant in Fernley, Nevada, and then to very quickly thereafter scale that pilot plant to build our commercial facilities, the 100,000 metric ton facilities. So that is the very clear use of proceeds.
Fantastic. So how far along is the permitting process in the factory?
We have begun, we have submitted, it's on this out there very publicly. We have submitted for what's called a conditional use permit to the city of Fernley. So there's two different permitting tracks. There is the local permitting track through the city of Fernley. Those are the planning and the building permits. The planning permits, basically, it's the community blessing the use on a particular site, saying that this use that we're proposing is consistent with community plans that the community has worked together to put, to demonstrate what they envision for the future of their community. The second part of those permits are the building permits, which is, yes, you conform to building codes, you can go build this. So we are going through that permitting process concurrently. We have the conditional use permit on file with the city. It is currently reviewing it. We expect there will be two public hearings. The first one we anticipate to be in mid-May. Concurrently, we are pulling together the building permits. We expect grading to start in May, and that the planning approvals and the building permit approvals will come kind of hot, back and forth, but together. That would, in a schedule that enables us to open by the end of December. So I would, encourage you to keep tracking our progress through the city's websites. It's all very public. And then the other permitting track that we're very focused on, again, the environmental permits, we'll need two different permits. through the Nevada Division of Environmental Protection. The first is a Class 2 air permit. The second is called a written determination. And before we have, so the application or the permit process where we are with NDEP is called, is we have just received our confidentiality agreement with the Nevada Division of Environmental Protection. There was some chatter in the ether sphere of, oh, you're trying to pull the wool over our eyes. No, actually, no, confidentiality agreement is vital for the success of new technology companies because our technology is highly proprietary. We hold it under trade secret. So we need to ensure, and Nevada State has put in place a process to allow new technologies to scale in a way that does not divulge the highly proprietary confidential technology information to others. So that process allows us to provide the information to the regulators so that they have what they need to, bless the process as, yes, this is safe. This is a process we want in our state. We see the economic value. We have seen the demonstration of the process itself that is not harmful to the environment or to local communities. And at the same time, though, prevents that the information from going public so that it protects our IP and allows us to be ongoing business concern. And we've been really thrilled with Nevada's ability to navigate those two different, sometimes competing interests. So we now have that confidentiality agreement, and that lays the groundwork for us to submit our air permit and our written determination. The air permit is a detailed technical evaluation of all the inputs and outputs from our process, and it shows that the outputs that come from our process are either mitigated or not produced at all in our case because we have such a clean process. The written determination process is a very deep double click into the technical process itself, understanding safety operations, how do you prevent for runaway events, understanding the technical process that allows the regulators, again, to say, yes, we've evaluated this in detail, and we are comfortable with it operating at commercial scale or at pilot scale, that it will not, in fact, harm health, life, safety of people or environment. And that is required under the federal EPA law, the Resource Conservation Recovery Act, RCRA. So both of those permits will be going in very shortly, and we expect to have them in place by the end of the year. Again, concurrent with the planning and building permit process through the city of Fernley. So all of this will be going many different work streams together in parallel at the same time, all driving towards end of 2021 operational capacity for the pilot plant. And we're on track to meet that.
Fantastic. I don't know if you can answer this in a minute, but I want to ask it anyway. What aspects of Biden's infrastructure plan will potentially affect what you guys are doing with ABML?
Great question. We could not be more excited by the executive orders and the studies, especially the supply chain executive order that came out. And I think on Monday, it came out in the Federal Register request for information. The key part we're looking at, there was a request for information on high capacity batteries, what is needed to scale high production of the batteries in the United States, everything from supply chains to global partnerships. So I think we will be submitting public comment. We have been working alongside policymakers and agency partnerships. We have clearly relationships with the DOE through our grant history. So that's where we're focusing our time, is the high capacity battery, the supply chain issues of establishing domestic sources, clarifying the regulations that apply to scaling new factories and storage and transportation of the batteries themselves. So there's a lot more in the infrastructure bill, but you asked where are we chiming in? That's where we're focusing our efforts.
Well, bravo to you, Menka, with such thorough knowledge that you have, and to your company. Would you please tell everyone the new name of your company that you're transitioning into and the email so that we can get all these questions directed to you?
Absolutely. So we're transitioning our name to American Battery Technology Company. And feel free to email me. My email address is msethi@abtc.earth.
Okay. And we'll have all this information too for our participants. But thank you so much. And we really look forward to hearing all of your updates.
Thank you so much for your time today. Have a good one.
Thank you. You as well. All right. Wonderful day so far.